These are 11.1 day 1 notes, and I'm starting on the back of the first page for summation notation. So this is a new Greek letter for us. It is called sigma, and we read it as sum of. So whenever you see this funky sigma symbol, it means to add up everything that follows. So it means the sum of. So it's a notation that we use to indicate the sum of the first n terms of a sequence. So basically, this sigma gives us a starting spot and an ending spot. So this value at the bottom of sigma is your starting spot, and then the value at the top of sigma is your ending spot. So it's telling you where to start and where to end. And then we're going to be adding up the amount of terms. So when you look at the first example, our starting spot is I is 1, and we're going to keep substituting values of I until we reach 4, because that's our ending spot. And we're plugging it into what follows sigma, which in this case is 3i. So what this looks like is we're going to plug in starting at 1, and we're going to keep plugging in. So there's 2. Keep plugging in. There's 3 until we reach the ending spot, which is 4. And sigma means the sum of, which is why I'm adding all of these terms together. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. What I have written here is called the expanded form. And when I actually add them all together, I get 30. This is called the evaluation. So directions in homework might say, find the expanded form and the evaluation. So you would want to do both of those. Starting with example 2, our starting spot is k is 3. So the first value that we're going to substitute in is 3. And we're going to keep substituting values until we reach our ending point, which is 6. So we have 3 squared plus 1. Then we have 4 squared plus 1. 5 squared plus 1. And then our ending spot is 6, so this is the last one. So now I'm going to evaluate each of these. 3 squared plus 1 is 10. 4 squared plus 1 is 17. 5 squared plus 1 is 26. 6 squared plus 1 is 37. So there is your expanded form, and then add them all together, and there is your evaluation. You should get 90. Example number 3, our starting spot to plug in would be I is 0, and we're going to keep plugging in until we reach our ending point, which is 4. So we have 1 over 0 squared plus 1. 1 over 1 squared plus 1. 1 over 2 squared plus 1. 1 over 3 squared plus 1, 1 over 4 squared plus 1, and then we're at our stopping point. So I'm going to just evaluate these. We have 1 plus 1/2 plus 1/5 plus 1/10 plus 1 over 17. So that's expanded form. And then our evaluation, when we actually add them all together, we get 158 over 85. On the next page, we have some properties that can be helpful. For some problems, it's your choice if you want to use the property or not. In other problems that we do, it'll be necessary to use these properties. So for now, I just want to show you what these look like. So any summation that you see that has a constant being multiplied, you can pull that constant out in front of the summation. The other two properties allow you to split up addition and subtraction so that each term gets its own sigma, its own summation notation. So let's look at example 1. This is going to reflect the first property, that 2 is a constant. So we are allowed to pull the 2 out in front of the sigma, and we would just be left with I after the sigma notation. So in this case, it just allows our summation work to be a little easier. So the 2 is in front, and now I'm going to start with substituting at 1 and then stopping at 3. This is pretty easy because it's just I. So when I plug it in, I have 1, 2, 3, and there's my stopping point. So now I can add all those together and get 6. 2 times 6 is 12. So again, it would be simple to just plug in as is, but that property shows us that we can pull that 2 out in front, and some problems in the future it will be necessary to pull that constant out in front. So number 2 is going to reflect the second property. So we have this addition, 3i plus 4i. This property allows us to pull them apart so that we have the 3i and then the 4i gets its own summation symbol. Now, you might also notice that the first property is also in play because we have a constant of 3 and 4. So I can pull that 3 out in front of the first sigma, and I can pull the 4 out in front of the second sigma. So this just makes things a little easier. So I have the 3 in front. I'm going to start plugging in at 1 and stop at 3. And then I have the 4 in front, and I'm going to plug in again, stopping at 3. And when you evaluate all this, you should get 42 as your sum.